Hello everyone, welcome back to Maintenance Foundation series. Now I will show you how to apply the factory access structure foundation successfully. Step 1. Study and understand in detail about machine. We need to understand about the machine and equipment by collecting and study on the machine and equipment documents. And those documents include firstly a technical drawing, include the mechanical, electrical, pneumatic, and hydraulic, etc. And the second one, the machine operating guideline, the work instruction, and the technical parameters. And the next one, let's see the troubleshooting guideline. The next one is the machine components list and catalog, dimension, technical parameters of each equipment, and also the programming, the configuration guideline of each equipment, the PLC program, the configuration file, and the last one is the recommendation from manufacturers. If we are not capable of the researching and fully understanding the machine ourselves, we should invite the manufacturer or the machine expert to train and sell. Previously, when I worked for a food and beverage factory with a hydraulic system, after having the drawings, structural diagrams, and operating principle of each valve, switch, pumps, I was able to understand around 80% of the system. But there are some equipment that are exclusive to the manufacturer. For example, the shut-off valve is designed specifically by the manufacturer. So I need the manufacturer on-site support to understand and make the maintenance easier. This is also the experience for some people new to the maintenance. We need to be fully hand over the above documents before starting to learn about the machine. And next, the step 2, 3, and 4 are 3 steps done in parallel. The step 2, we need to make a comprehensive components list. Please take note, not allowed to miss any components. Stand up, take a few A4 sheets, a pen, and spend a few hours on the machine, checking on the nut, running of the machine, listing the names and the quantities of each in detail. For the big equipment such as pumps, impellers, tanks, to the smallest details such as fittings that convert from watt diameter to watt diameter. Go around the machine first, then go to the electrical cabinet. Check the PLC from which manufacturer, which model, and write down the model of each valve, each CP, each contactor, or how many are there, including the electrical cabinet, cooling device, the electrical cabinet cooling filters, etc. We can divide the equipment into 2 types: consumable and non-consumable. Consumable are equipment have the characteristics is that they wear out over time and need to be replaced frequently. For example, lubricant, filter, etc. And non-consumable is the equipment that does not wear out or wear out insignificantly. Please do not confuse about the natural wear and forced wear. Consumable are equipment that wear out naturally and non-consumable equipment that wear out are fault, wear, and tear. For example, bearings. Some opinion that the bearing is consumable. That is not correct. If we operate with the correct load and lubricate them frequently, the possibility of the bearing is worn out or being damaged is very unlikely. A technical problem here is such as the not proper the lubrication cause the wear and tears. And similar with the belt. If the roller and the both sides are aligned uniformly and accurately, the tension is sufficient, and the surface in contact with the belt is not round or scratchy, it will take a long time for the belt to deform. Otherwise, if the tension roller at both sides is misalignment, the tension will accept it, or the belt is loose. It's sure that the belt will break and be damaged. And step 3, specific quantity. During the on-site survey, in addition to counting the number of the equipment in this step, we also need to determine the current data of this equipment as following here. The first one, the maintenance schedule. It means the maintenance schedule of that equipment. For example, a motor will have the thermal scan every 3 months, 4 times a year. Measure the bearing vibration every 6 months, mean twice a year. That is the maintenance schedule. This parameter will be included in the maintenance plan, also known as the PM, preventive maintenance. In detail about the type of the maintenance, I will talk in detail in the next foundation work on the management. And the next one is the manufacturer recommendations. In the recommended number from the manufacturer, for example, a pressure switch is recommended by manufacturer to operate 10,000 times on and off. Or a proximity sensor, we can use maximum is 10,000 hours. Those number was pay attention to. With those number, we will convert into a maintenance schedule based on the actual operating time from the production plant. If this parameter is not available, we should email or call directly to ask the manufacturer about it. And the next one is a breakdown frequencies. Let's see the frequency of the down equipment cause the machine to stop. This can be a non-function equipment that can be repaired or completely broken. For electrical equipment, for example, an inverter. If the inverter malfunctions, it stops the light, and when the inverter resets and works well again, it still counts as a breakdown. This data is input for analysis and making appropriate the maintenance plan. So, where do we get this data? It's from our broken machine information recording system. Some companies can use the SAP module, AMM, Oracle, Microsoft Dynamics, or most simply store it on an Excel file or a certain checklist hanging on the machine. The next one is a service lifetime. That's the availability of the equipment on the market. And easier to understand, example. For Rockwell Automation equipment, their will be 4 service cycle status. The first one, active, most current offering within a product category. The second status is active major, product is fully supported, but a newer product or a family exists, gain value by migrating. And the third status is end of life, discontinue that announced, actively execute the migration and last time purchase. Product generally orderable until the discontinue date. And the final one is a discontinue status. Product no longer manufacture or produce. Repair or exchange service may be available. That's the service lifetime of the equipment. For more detailed example, I have one control net communication module of the Rockwell Automation brand. That model is 1756 CN2RXD. At the time I make this lecture, the state of this module on the home page of the Rockwell Automation was active major, which means this module is still sold on the market, but a new replacement module has been produced. And of course, this new module will completely replace the current module in the future. Another example, a communication module model 1756 CNPK. Currently, the status is end of life. It means if you plan to stop production in 9 months, and there are replacement module 1756 CN2K. In summary, this parameter will help us to understand when the equipment is no longer in production, meaning when we will no longer have spare parts to plan for timely replacement. You can see it on the manufacturer website or equipment catalog, but if not, we should list the Excel file for all equipment or a brand and send an email to ask manufacturer directly. This parameter is extremely important for electrical and automation equipment. And the final one is the procurement lead time. This is the time to buy spare parts. It includes from the step when we receive a quotation from the supplier until we receive the good in hand. It depends on each company. We will have different processes, but I can share a general process. The step 1, after receiving a quotation from supplier, we do not share the time of this step, but because it depends on the skill and relationship of the maintenance engineer and the supplier, it will be faster or slower. We can submit it to superior for approval. And step 2, the procurement department issue a purchase PO, purchase order, and send it to the supplier. And step 3, supplier prepare the good, can produce equipment if the supplier is a manufacturer, can buy goods if the supplier is just only a trader. And step 4, ship the good from supplier to the factory to us. In this step, if the spare part is local, it will be very easy. But if it is abroad, we have different way to transportation corresponding to a different time. The fastest transportation by air is meant by airplane. The secondly by sea is meant by boat. The thirdly by road is meant by like a vehicle. We should get a quotation for all 3 ways, and depending on the urgencies, we decide which way to go. In the 4 step above, only step 2 here common process for on spare part. So we will know exact the number of on equipment. The remaining 3 steps will vary according to each equipment and order. Some factory will have a procurement team to take care of this. They have a file of the information about how many days it takes for each equipment. That is the standard order. And every year the procurement department will automatically contact to the supplier to update the price, the lead time. Lastly, the step 3. Next we come to the step 4. We collect all the equipment specifications and parameters. The first one is brand. The brand of the equipment, in another word, the manufacturer of the equipment. Part number or serial number. And next one is the model. And the final one is specification and parameters. For example, input wanted. Maximum with withstand the current, min-max temperature, pressure, and the output from 0 to 24 milliampere or like volt DC or 4 until 20 milliampere. The technical specification section that everyone needs to pay attention to. The first one is record on the essential installation parameters. For example, for a temperature sensor with the transmitter, it's necessary to record the setting range inside the transmitter. For example, from 0 to 150 degrees Celsius. For an inverter, it can be 60 Hz frequency. 3 speed level at 30, 60, or 90. For self-produced equipment that do not have a model or brand, we sure to take the picture and measure the essential parameters. That will help us to have a database to compare when something goes wrong or we suspect someone had changed. An example, when I previously worked for a food and beverage manufacturing company, the temperature and the humidity required of the clean room were very strict. And in the ASU provide for this cleaning room, I have many parameters that no one has saved before. So when the problem occurs, I don't know what is the correct parameter. Another best news is the ASU have absolutely no PID control. I have to adjust step by step, and it took more than 2 hours to find the optimal parameters. Therefore, please back up all the parameters. And step 5, create a BOM, bill of material management system. We say it's a system, but we can start with an Excel file. Just one Excel file is enough to be a system if we manage it well. If the budget is better, we can use a management management system such as SAP, Oracle, or Microsoft Dynamics. And step 6, the final step, is evaluation and updating. The equipment structure will change, cannot be fixed. Some possible change are change the equipment because of the new equipment is more optimal, or we upgrade and expand the system and new machines to increase the capacity. And to manage this change, we need to do to show consistently and sustainably. I would like to emphasize this because it's the core of this foundation. We have spent a lot of time and manpower to do the previous 5 steps before, but everything will be destroyed if we do not well in this step to maintain the foundation. For example, it took us 2 months to build the system, but only 1 later we have a new equipment that we forgot to update into the list, and accidents that the equipment caused a breakdown and stopped the computer, the lights, because it did not have the equipment maintenance plan, mean that our whole system is not reliable anymore. A valuable experience was when I worked at an electronic equipment assembly company with nearly 5,000 big and small equipment. Managing the access structure is very complicated, but the key issue here is the management system is not uniform across departments of the factory. More specifically, the processing of department is managed by Excel file. The maintenance is managed by one CMMS system. Process is based on the third, like based web application. When there is any change in the equipment list, this pack and other packs are not informed or informed and updated manually by human. Pack here is mean the department. So the consequence is that the 3 departments do not have the same list. And of course, the loss and like missing the lost the equipment, missing the maintenance schedule happen very often. So in conclusion here, the whole factory should have one common system for all, and the update process must be like extremely clear and announced to every department. If the process is manually, it's the best to control it with an approval form by the department head and the plant director. To ensure there are no errors in the process, there should be a periodic access audits. Depend on the number of access, we design the frequency, but at least once a year. And small tip here, if the technical department have divided to small team inside, for demo mechanical team, automatic and electrical team, general service team, then this management should be divided to X team. And the management and auditing should also be easier. Another thing to note, that's the updating price, lead time, and contact number should also be done annually. That's the entire process of the building a factory access structure management system.